To isolate the grounding for the subpanel, the ground rod separate from the main ground rod can be used. Install a copper-clad steel ground rod that is 8 feet or longer near the subpanel. Connect a bare copper wire that is a minimum of number 8 AWG from the subpanel ground bar to the ground rod. Use a ground clamp or compression connector to secure the wire to the ground rod. The ground rod should not be connected to any other electrical system. The National Electrical Code, or NEC, requires a main circuit breaker in any subpanel that has more than 6 circuit breakers. Since the subpanel will have more than 6 circuit breakers, install a main breaker. Consider also the following points. Use combination type arc fault circuit interrupter, also known as a SI, and ground fault circuit interrupter, also known as GFCI, circuit breakers for all circuits in the media room because they provide protection against both arc faults and ground faults. Over long distances, voltage drop can become significant. Consider using larger conductors for the feeder wires from the main panel to the subpanel to minimize voltage drop. For example, consider using number 6 AWG. Install ground fault circuit interrupter, also known as GFCI, outlets in the media room to provide additional protection against electrical shocks. For a recommended breaker schedule, consider the following. Firstly, use 220 amp circuits for audio and video components. Secondly, use 115 amp circuit for lighting. Thirdly, use 120 amp circuit for climate control, such as an air conditioner. Fourthly, use 120 amp circuit for other appliances, such as a projector. This configuration uses a total of 6 20 amp breakers and 115 amp breaker, which will require a 100 amp main breaker. It is important to adhere to local electrical codes and regulations when installing electrical equipment. Consult with a qualified electrician for personalized advice and to ensure safe and compliant installation. When installing a subpanel, safety should be a top priority. Firstly, always disconnect power to the main panel before working on any electrical components. Secondly, use properly insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. Thirdly, double-check all connections to ensure they are secure and properly tightened. Fourthly, clearly label all circuits in the subpanel for easy identification. Fifthly, test all circuits after installation to verify they are functioning correctly. Sixthly, keep a detailed record of the subpanel installation, including wiring diagrams and breaker schedules for future reference. Remember to follow these safety precautions to prevent electrical hazards and ensure a safe installation process. Ensure that all wiring and connections are performed in accordance with the National Electrical Code and any local regulations. The use of properly sized conductors is critical for safety and performance. The feeder wires from the main panel to the subpanel must be sized appropriately for the amperage of the subpanel. Consult the NEC tables for proper conductor sizing based on the ampacity and the type of insulation used. Using conductors that are too small can lead to overheating, voltage drop, and potential fire hazards. Also, ensure that all connections are properly torqued to the manufacturer's specifications. These connections can cause arcing and overheating, which can also lead to fire hazards. The grounding system is essential for safety and proper operation of electrical equipment. A properly installed grounding system provides a low impedance path for fault currents, helping to protect against electrical shock and equipment damage. The ground rod should be installed in an area where it will have good contact with the earth, and it should be protected from physical damage. The grounding conductor should be securely connected to the ground rod and the subpanel ground bar. It is also important to bond all metal parts of the electrical system together, such as metal conduit, enclosures, and equipment grounding conductors. Bonding ensures that all metal parts are at the same potential, reducing the risk of electrical shock. When selecting a subpanel, choose one that is appropriately sized for the intended load. The subpanel should have enough breaker spaces to accommodate all of the circuits that will be installed. It is also important to choose a subpanel that is rated for the appropriate voltage and amperage. Overloading a subpanel can lead to overheating and potential fire hazards. The main breaker in the subpanel should be sized to protect the subpanel and the branch circuits. The main breaker should be rated for the maximum current that the subpanel can handle. Branch circuit breakers should be sized to protect the individual circuits and equipment. The NEC specifies the maximum allowable ampacity for branch circuits based on the wire size and the type of load. Using circuit breakers that are too large can allow excessive current to flow, which can damage equipment and cause fire hazards. Arc fault circuit interrupters, also known as size, and ground fault circuit interrupters, also known as GFCIs, provide enhanced protection against electrical hazards. Size protect against arc faults, which are dangerous electrical arcs that can cause fires. GFCIs protect against ground faults, which are electrical shocks that can occur when there is a leakage of current to ground. The NEC requires size and GFCIs in many areas of the home, including bedrooms, living rooms, and bathrooms. Using size and GFCIs can significantly reduce the risk of electrical fires and shocks. Proper labeling of circuits is essential for safety and convenience. Each circuit breaker in the subpanel should be clearly labeled with the equipment or area that it serves. This will make it easier to identify and troubleshoot circuits in the future. A circuit directory should be created and kept near the subpanel. The circuit directory should list all of the circuits in the subpanel, their breaker numbers, and the equipment or area that they serve. When installing electrical equipment in a media room, there are several specific considerations to keep in mind. Media equipment is often sensitive to voltage fluctuations and electrical noise. Using a dedicated subpanel can help to isolate the media equipment from other electrical loads in the home, reducing the risk of interference and damage. It is also important to use high-quality surge protectors to protect media equipment from power surges. Surge protectors should be installed at the subpanel and at each individual piece of equipment. Proper ventilation is essential for preventing overheating of media equipment. Media equipment can generate a lot of heat, especially when it is used for extended periods. Ensure that the media room is adequately ventilated to prevent overheating. Consider using fans or other cooling devices to help dissipate heat. Cable management is important for keeping the media room neat and organized. Use cable ties, cable trays, and other cable management products to keep cables organized and out of the way. This will help to prevent tripping hazards and make it easier to access and troubleshoot equipment. The location of the subpanel should be carefully considered. The subpanel should be located in a dry, accessible location. It should not be located in a damp or humid environment, as this can lead to corrosion and electrical hazards. The subpanel should also be located in an area where it is easily accessible for maintenance and repairs. The height of the subpanel should be in accordance with the NEC requirements. The NEC specifies the minimum and maximum height for electrical equipment. The subpanel should be mounted at a height that allows for easy access and visibility. When installing a subpanel, it is important to obtain the necessary permits from the local building department. Electrical work is often subject to inspection to ensure that it is performed in accordance with the NEC and local codes. Obtaining the necessary permits will help to ensure that the subpanel installation is safe and compliant. Consulting with a qualified electrician is always recommended when installing a subpanel. A qualified electrician can provide personalized advice and guidance based on the specific circumstances of the installation. An electrician can also help to ensure that the subpanel installation is safe, compliant, and properly sized for the intended load. The service panel must have adequate capacity for the new subpanel. The existing service panel must be sized to handle the additional load of the new subpanel. The load calculation should be performed to determine the total load on the service panel. If the existing service panel is not large enough to handle the additional load, it may need to be upgraded. The feeder wires from the main panel to the subpanel should be protected by a circuit breaker in the main panel. The circuit breaker should be sized to protect the feeder wires from overcurrent. The size of the circuit breaker should be based on the ampacity of the feeder wires. The feeder wires should be installed in conduit or cable. Conduit provides physical protection for the feeder wires. Cable is a type of wiring that is suitable for use in dry locations. The type of wiring used should be in accordance with the NEC and local codes. The subpanel should be properly grounded. Grounding is essential for safety. The subpanel should be grounded to a grounding electrode system. The grounding electrode system should consist of a ground rod, a ground plate, or a metal water pipe. The grounding electrode system should be connected to the subpanel with a grounding conductor. The grounding conductor should be sized in accordance with the NEC. The subpanel should be bonded to all metal parts of the electrical system. Bonding ensures that all metal parts are at the same potential. This reduces the risk of electrical shock. Bonding should be done with a bonding conductor. The bonding conductor should be sized in accordance with the NEC. The subpanel should be properly labeled. Labeling is essential for safety and convenience. Each circuit breaker in the subpanel should be labeled with the equipment or area that it serves. A circuit directory should be created and kept near the subpanel. The circuit directory should list all of the circuits in the subpanel, their breaker numbers, and the equipment or area that they serve. The subpanel should be inspected by a qualified electrician. An inspection will ensure that the subpanel is installed correctly and safely. The inspection should be performed before the subpanel is energized. The subpanel should be maintained on a regular basis. Maintenance will help to ensure that the subpanel continues to operate safely and reliably. Maintenance should include inspecting the subpanel for any signs of damage or wear, tightening any loose connections, and testing the circuit breakers. Firstly, proper planning and preparation are crucial for a successful subpanel installation. Secondly, ensure that the existing electrical system has the capacity to support the additional load of the subpanel. Thirdly, select a subpanel that is appropriately sized for the intended use and meets all applicable safety standards. Fourthly, follow all NEC guidelines and local electrical codes during the installation process. Fifthly, use high-quality materials and tools to ensure a durable and reliable installation. Sixthly, double-check all wiring connections and grounding to prevent electrical hazards. Seventhly, properly label all circuits and breakers for easy identification and maintenance. Eighthly, test all circuits and devices after installation to verify proper functionality. Ninthly, schedule a professional inspection to ensure compliance and safety. Tenthly, document the entire installation process for future reference and troubleshooting. Remember that safety is paramount when working with electricity. If there's uncertainty or unfamiliarity with any aspect of the installation, consult a qualified electrician.